Have you ever just stopped and thought about how the AI on your phone or in your search bar got so smart? I mean, it feels like it happened overnight, right? But what you've been witnessing is actually a huge creative explosion in artificial intelligence. So today, we're going to pull back the curtain and unpack that exact story.
So let's just start with that big question. How did AI get so good at understanding us? Think about it. From the predictive text that literally finishes your sentences to search engines that just get what you're looking for no matter how weird your question is, this tech is everywhere. So where did it all come from?
Okay, at first glance, this slide looks like total chaos, doesn't it? It's just a tangle of names and arrows going everywhere. But what you're actually looking at is the family tree of modern AI language models. And while it looks super complicated, the entire story really hinges on just a couple of key breakthroughs. So stick with me, and I promise, by the end of this, you'll be able to read this map like a pro.
Now, to really understand this revolution, we first have to appreciate the problem. For decades, human language was one of the toughest knots for AI to crack. It's not like math, with clear logical rules. Language is slippery, it's ambiguous, and it's all about one crucial thing: context.
And here is the perfect example of that challenge. Just look at the word bank. How in the world does a computer know if you're talking about a place to get cash or the side of a river? The word itself is identical. The only clue is the other words around it. And solving this context problem, well, that was the absolute key to unlocking everything that came next.
So, how'd they do it? How did they solve the context problem? Well, the answer came from this brilliant idea that researchers borrowed from a totally different field of AI, computer vision. The science of teaching computers how to see. This idea is called pre-training, and it changed the game completely.
This slide is a great way to think about it. See, to teach an AI to recognize a cat, you don't just show it a million cat photos. First, you have to teach it the absolute basics, how to identify simple things like edges, corners, and textures, which is what you're seeing on the left. Once it masters those building blocks, it can start piecing them together to understand the whole concept of a cat. And the big idea was, what if we could do the exact same thing for language?
And that's exactly what pre-training is. Before you ask an AI to do a specific job, like translate French or answer trivia questions, you first you basically make it read the entire internet. You feed it this massive library of text and just have it learn the fundamental patterns of language: grammar, facts, how words relate to each other. It builds a general, foundational understanding first. This was the light bulb moment.
So our first hero in this story arrives in 2018. A model named Elmo came along, and it was one of the very first to successfully use this pre-training idea to give words context-dependent meanings. It was a huge, huge step forward.
Let's go back to our bank sentence. Before Elmo, an AI had just one static, unchanging definition for the word bank. Elmo was different. It was designed to understand that the meaning of a word depends on its neighbors, the words that come before it and the words that come after it. But the way it did this had a really crucial limitation.
You see, Elmo had this key limitation. It was kind of like trying to read a sentence with one eye closed. As this slide shows, it would analyze the context to the left of a word, and then in a totally separate process, it would analyze the context to the right. Then it would just kind of smush those two views together. It wasn't able to process the entire sentence and all its rich context at the exact same time.
And that brings us to the main event. Later that same year, 2018, a team at Google released a model that solved Elmo's biggest problem. It was called BERT, which stands for Bidirectional Encoder Representations from Transformers, and it was a true revolution. And that word, bidirectional, that's the key to the whole thing.
This slide just illustrates the difference perfectly. While ELMO looked left, then looked right, BERT could see the entire sentence, left and right, all at once. It was truly bidirectional. So it didn't just see the word bank. It instantly understood bank in the complete context of to deposit money. It saw the whole picture from the very start. And that one ability, it changed everything.
So how did it learn this amazing skill? Well, BERT's pre-training was basically like playing two clever language games over and over. First, fill in the blanks. Researchers would take a sentence, hide a few words, and then ask BERT to predict what the hidden or masked words were. This simple game forced it to learn really deep relationships between words from all directions. Second, they played Are These Sentences Related? It was given two sentences and just had to predict if the second one logically followed the first. By playing these two games billions and billions of times, it developed this deep, intuitive feel for how language actually works.
So the breakthroughs of Elmo and especially BERT, they didn't just create a single better model, they provided a recipe, a blueprint for how to build powerful language AI. And what happened next was just an explosion of innovation.
Hey, remember this chaotic chart from the beginning? It should make a lot more sense now. You can see Elmo way up at the top. And then right there, in the center of it all, is BERT. Just look at all the arrows pointing out from it. BERT became the foundation, the common ancestor for dozens and dozens of new, more powerful, and more specialized models. It kicked off a true Cambrian explosion in AI.
So let's just quickly summarize that pivotal year, 2018. First, you had ELMO, which pioneered the idea of using context to understand what words mean. And then BERT came along and introduced true bidirectionality, which gave AI a much deeper, more complete understanding of language. It was this incredible one-two punch that changed the field forever.
And this is why all of this matters too. The ideas that were pioneered by ELMO and then perfected by BERT are literally the foundational DNA inside almost every advanced AI language tool you use today. The improvement was so dramatic that when Google first integrated BERT into its search engine, it called it the single biggest leap forward in years. It allowed Google to understand your questions like never before. It all stands on the shoulders of this bidirectional revolution.
So, we'll leave you with this final thought. The journey from ELMO to BERT was this massive, massive leap, teaching machines to finally understand the deep, complex structure of our language. But the next frontier is even bigger. And the question now is, what's it going to take for AI to go from simply understanding our language to truly understanding us?